Bismillahirrahmanirrahim. This is the third part of solving recurrence equations. So that is recursion tree method. Hopefully you guys are well familiar with this one and due to my previous lectures on merge sort and quick sort, because we have been using this method for solving those recurrence equations. Okay, so basically what we do is we convert our recurrence equation into convert this recurrence equation into a tree in a step-by-step method, uh, and then we calculate the time at each level, and then we just add up all the levels and convert. We find some series and then converting that series into its equivalent expression. We find the time complexity of that one. Recursion tree methods, the cost of a time recursive execution of an algorithm. This method is good for generating the guess for the substitution method. This method is not very reliable, especially like methods that use the algorithm that uses ellipses. So this is not good for that one. So it also promotes the intuition. Let's start with an example, and then we'll be able to you will be able to recall what we learned in previous lectures. So here we are formally doing that thing. So let's say we have an equation that is t of n is equal to t of n by 4 plus t of n by 2 plus n square. So I think you can understand that this n square is the combined cost of divide and conquer. So this is one sub problem, and this is going to be the second sub problem. So here in this example, the two sub problems are of two different sizes. So if these two sub problems were of the same sizes, then we could have been added those two just like we did in the merge sort. But here the sizes are different, so we cannot add them. Okay, starting with the very first level, so we need to calculate t of n. So this would be the first node of the tree. So you may consider it as a figure 1. Okay, now as we need to know the value of t of n, we just open this equation. When we open this one, we will face this cost, that is n square, and then we will face two sub problems, t of n by 4 and t of n by 2. So let's call it figure 2. So this is your first step of creating tree from this recurrence equation. This is the step 2. In the next step, so we have n square at the root, then we have t of n by 4, putting t of n by 4 in place of n. So this is the thing that you have been doing again and again. So t of n is equal to t of n by 4 plus t of n by 2 plus n square. So putting, because we need to solve this one, so we are putting n by 4 in place of n. So n by 4 is equal to t of n by 16 plus t of n by 8 plus n by 4 whole square. Okay, now what we need to do, t of n by 4, so replacing this one, and at the same time we just put n by 2 also here. So it is t of n by 2 is equal to t of n by 8 plus, here we put t of n by 4 plus n by 2 whole square, replacing n with n square. So we just replace it here. So we will get n by 4 whole square here, the time complexity of n by 4 whole square here, and in replacement of this one we will be getting n by 2 whole square. Okay, and at the same time we will be getting two sub problems here of t of n by 16 and t of n by 8, and here we will be getting two sub problems of t of n by 8 and t of n by 4, this one here. And keep on doing like this one. I think you should be when you will be doing it on your papers, so you should go for one step deeper in this one. So finally you will get theta of 1 at some level, and then this one will be resolved into the equation forms. So here we can see that the time complexity of this level, overall this level, is n square. How about this one? This is n by 4 whole square plus n by 2 whole square. So it would be 5 by 16 n square. And if I resolve this next level, so adding the opening, first of all I have to replace this one with the left hand side of the equations, and then if I solve it, then it will become 25 by 256 n square, and so on. So this implies that t of n is equal to, I'm just taking common n square as a common from all terms. Here you can see n square here, n square here, and n square here. I'm just taking it as a common, so your rest is 1 plus 5 by 16 plus 5 by 16, so whole square. So this is 5 by 16, 16 are 256, and 5 5s are 25, and next would be 5 by 16 whole cube plus so on. So applying geometric series on this part, so we can get a constant number. So it would be n square, and then there would be a constant. So you can calculate the exact value of this one. Okay, where c is equal to 1 by 5, 1 plus 5 by 16 plus 5 by 16 whole square, and so on. So here we can see that the time complexity of this algorithm is theta, algorithm whose recurrence equation is was given here, that is t of n is equal to t of n by 4 plus t of n by 2 plus n square, is actually theta of n square. Let's take another simple example in a quick way. Let's say our equation is w of n is equal to w of n by 3 plus w of 2n by 3 plus n. So first we do the same process that we done there. So the first one would be, we need w of n. So this is our figure 1. Now replacing it with the left hand side, we will be facing the cos, that is n. Guys, please don't forget to mark the circles. So w of n by 3, w of 2n by 3. So let's call it figure 2. Converting it into figure 3. So this is n, so n by 3. Just do it using the equations. 2n by 3. So putting we need the w of n by 3, so putting n is equal to n by 3 here, you can get this part. So this is, so replacing n with n by 3, so it will become n by 9. So w of n by 9, and it will become w of 2n by 9, and here in this form replacing n with 2n by 3, so it will become 2n by 9, 2n by 9, and it will become w of 4n by 9, and so on. Definitely this branch is going to be a shorter one. For reaching w1, this would be a little bit longer one, and this would be the longest branch to reach to w of 1. This branch is going to take the most time. So calculating level by time complexity at time at each level. So this is n by 3 plus 2n by 3, that is again n. So if you resolve it, this is again n, and just keep on doing, giving you n's. So what we need to know is, we need to know how many n's are there. So that is the height of the tree. So height of the tree is always determined by the longest branch, and the ratio of the longest branch in this is to n by 3. So that means the height would be log of 3 by 2 n. So our t of n, our t of n is equal to, sorry, not t of n, here it is w of n. So w of n is equal to n plus n plus n plus so on up to n. So there are log of n 3 by 2 n's. So we can say that the time complexity of this algorithm is theta n log of n. Okay guys, so so this is how the recursion tree is can be used to solve the recurrence equation. So this, you can see the quick sort part and the merge sort part, so that would be helpful for you guys. So if you have any query, you can ask me in the comments or in the group also. Just mark the time and write your comment, so I will be answering those queries. Okay guys, thank you very much. Stay happy, stay blessed. Allah Hafiz.